Good evening, everyone. Good evening. Apologies for the usual last-minute technical glitch. I think we're ready to go now. I'm Greg Paul. I'm the president of the Acorn Renewable Energy Co-operative here in Middlebury, and it's a great pleasure to see all of you here tonight. We're going to be talking about cold climate heat pumps for your home. Hopefully by the time you leave you'll be better informed about what's involved. I've been involved in renewable energy issues for many years, and conventional wisdom about air source heat pumps has been for many years that they really didn't work very well in cold northern climates, and that they were mostly good for areas south of New England. Well, there have been some recent developments in the technology, and there is a new category of air source heat pump called a cold climate heat pump that works very well in cold northern climates like Vermont's. And so that conventional wisdom has been turned on its head with this new technology. We've got a couple of very knowledgeable individuals here tonight to help talk you through some of the details. Gary Barnett will be our first presenter. He's a member of the Acorn Energy Co-op board, and he will give the overview of and the background of some of the more technical aspects of this. And then Rick Shappy from structural engineering here in Middlebury will fill in some of the gaps that Gary may not have covered, and he will be happy to answer your questions as well. We have a slight technical issue here with the microphones, so if you do have a question, I guess I should say, if you have a question, try to hold it until the end of each presenter's section. But if you're really confused about something, you can raise your hand and stop them in the middle of the presentation and ask your question. But if you do that, we're going to have to give you this microphone to ask the question, otherwise it gets lost on the recording. So please bear with us and be patient. I think without further ado, Gary Barnett.
Thank you, Greg. Yes, good evening, and thank you all for coming. A couple questions for you. Anybody here have a heat pump? There's one. Good deal. And how long have you had it?
I have it in a rental unit. It's been there since last fall.
People happy with it? Your renters like it a lot and reduce their bills substantially?
Yes.
Good deal. And I guess the rest of you are considering it then, huh? Good deal. Well, thank you very much. Without further ado, we'll go through this presentation here. So the heat pump moves heat from one place to another. It can remove heat from a room as well as bring heat into a room, so it's got a cooling aspect to it as well as heating, which is a bonus. Does not produce heat from combustion like boilers, furnaces, or wood stoves. And the efficiencies are over 100%. When they talk about cold climate heat pumps and things, they talk coefficient of performance, and that typically for a cold climate heat pump is 2.5 to 3, and that really says that it's 2.5 to 3 times more efficient than just radiant electrical heating. So it's really quite significant advantages over conventional electric heating. There are ground source from water to buried pipes containing antifreeze, and those tend to be a lot more expensive. You've got a well that you've got to dig and pumps and things that are going to make it initially a lot more expensive. The air source from the outside air is what we'll be concentrating on tonight, and both of them have an outside unit that's the compressor, and the inside unit, which is got a fan and delivers either the heat or cool. So, and because of that, having the compressor outside, these units are a lot quieter. Really, the only thing that is in the room is a fan that's making noise. So they're a lot quieter than most of you are probably familiar with window air conditioner type things that can be pretty loud, but these are much quieter. Like Greg said, they typically did not work well in cold climates, but with the technical advances, they've become much more efficient in cold climates. Ductless mini-split cold climate air source. So there's no ducts in the system. The head that's mounted on the wall, I'll show you a picture of that next couple slides, is all that there is, and there's tubing that runs from that and a condensate drip line, but no ducts. So retrofitting in existing homes is typically easier than trying to run ducts and things. So there's, on the left is the indoor unit, and that gets mounted up on the wall typically. The outdoor unit is the compressor, and then there'll be a controller. And there you can see a unit mounted up on the wall, and they're typically mounted up high like that. There is a compressor outside in a poorly installed situation because you really want to have airflow around it. Snow shouldn't be building up around it. It is good that they put a roof on it to keep the snow off of, but it should have been higher up off the ground. And there's a simplified drawing of how it works. You've got a compressor in it that compresses the refrigerant, and when it condenses into liquid, the phase change is what does the work as far as delivering heat or cool to the source you're doing. And what's made these able to heat and cool is there's a reversing valve in there that you can change the direction of flow. So how it works: in the summer it cools, in the winter it heats, and basically does the opposite thing in winter that it does in summer. And this is from, I believe, this is from the Efficiency Maine study. There was one of the really well-researched and documented studies that they did, and you can see that the savings are significant. I mean, if it wouldn't have come from such a reliable source, I would have been a doubting Thomas on these numbers. But Efficiency Maine did an extensive study and very big reductions in oil usage.
Gary, can you read some of that out and try to see that?
Yeah. So in a high energy use home, probably one that doesn't have any weatherization done to it, if they're using 1,300 gallons, it's reduced to 349. And in a high energy use home, one of the really important things is the other efficiency measures that should be done in combination with energy source like the cold climate heat pump. You want to get your insulation in your walls, in your attic, air infiltration, reduce all those things, and you'll have like this on the right, low energy use home, 500 gallons down to 14.
Are you going to show the compensatory amount of electricity you use?
I
mean, it's not a free lunch.
It's not a free lunch, no. I'm not sure if I have that in there. It might be. And Rick and Jared might be able to address that, maybe. So the coefficient of performance, what I talked about, is a ratio, and the higher the COP, the higher the efficiency of the unit. And once again, they're in the 2.5 to 3 COP is the ones that I'm familiar with as far as their performance. The SEER, seasonal energy efficient ratio, is the heat pump's cooling efficiency. And once again, higher numbers are more efficient. And the heating season's performance factor is the heating efficiency. So they're all higher numbers are better when you're looking at them. and shopping for them. This is a chart that shows capacity versus outdoor temperature, and on the left you see the coefficient of performance and the heating capacity in 1,000 BTUs per hour on the right. So you can see as the temperatures drop, the coefficient of performance goes down and the heating capacity goes down. But in the 5 to 25 type numbers, you get into it all goes above a coefficient of performance of 2. And even at -5, you're pretty close to that. So that's twice as efficient as an electric heater, even at those kind of cold temperatures. This is a lot of information in a little space. That's what that is. But it's total costs of doing different measures, basic air sealing, projected annual savings. So it gives you a payoff time. And obviously, the lower the number of years for the payoff, the better it is. Basic air sealing, once again at the top, and that's your efficiency measures that are so important to do in conjunction with energy work. Air source heat pumps right behind that at 2.1 years. Burner conversion only, oil to natural gas, also a fairly high payback, and then it goes down. Wood stove. If you, I don't know, does you want me to go through that whole list with you, or is looking at it for you sufficient? Yes.
Do you have wood from the wood stove on that list? I can't.
Yeah. The question is there wood stove in there? And it is 1, 2, 3, 4. Using a wood stove to provide 50% of the heating has a 2.8 year payback. So wood's still a very good option, especially as oil prices go higher. It gets even better. Let's see, other things that are in there. Wood pellet stove. Once again, doing 50% of the heating is a 4.6 year payback. What else we got in there? Insulation projects are 6 years typically. What else might be interesting? Solar PV has got a 10-year payback when for running and ductless air source heat pump. So pretty good paybacks on a lot of the efficiency measures. Oh, don't do that. What did I do, Greg? Stop that. There we go. Issues to consider. Net zero or near net zero homes are ideal. Once again, that's a home that's built to real high efficiency standards, high R values in the walls and the ceilings, very tight. Low air changes per hour, probably has air-to-air heat exchanger because the house is so tight that you need to get fresh air in another way than through the leakage that happens through windows and doors. Thermostat location, because these units are going to typically a zone type heating. If it's in a large room like this, it would take care of it, but if your thermostat for your furnace is in the same room with the air source heat pump, indoor units in, that's going to affect how the furnace runs. So you need to adjust things there. Open versus divided floor plans. Open, obviously, the heat's going to travel better versus a older home with a bunch of small rooms. It's hard to move heat through doors and down hallways and around corners. Common areas are best. Improper installation can lead to wasted energy, and how it integrates with the existing heating and cooling system. That's thermostat location and things like that. And typically, put it in a room that you spend a lot of time in is going to be a good way to start. Some of these units can have multiple heads on them. So you can get 2 different areas in a home done. So those, there's options that. Energy efficient heating projects. So this is the main study that was quoted earlier with all those figures. Very good things. Southeast Alaska did a study, and Efficiency Vermont has done one too. So those are all, if you want to look at some of these studies, we can get you those links to take a look at them more in depth. The bottom line of all of them is they've concluded that they're very effective in cold climates and at a reasonable cost and a fairly rapid payback. Questions? Yes. Let me.
What's the circulating fluid? Is there just one fluid circulating in the house?
Yep, it's
temperature inside the house.
The refrigerant R410a is what they're typically using now, and
what's the temperature of it inside the house? Where it's circulating inside the house? Is that a fixed temperature?
No, it doesn't. It depends on what you want. If you're heating with it, it's providing warmth to the house, so it's going through a fan system. If you're cooling with it, it's bringing cold in. So it varies. That is the essence of the whole thing.
And I'm thinking heating. Like if you have a regular hydronic furnace, it's set for a particular temperature of
Yep.
water. Is this the same, or does that temperature vary?
It varies. You can you can set a temperature that you want the thermostat to meet. As long as you meet, it puts out enough heat to bring it up to that temperature. It shuts itself down just like a regular.
Yeah, but I'm asking about the temperature of the circulating fluid itself. Do you know what that is?
What he's talking about is like a basic boiler.
Yeah, it's
set it at a certain temperature. He wants to know if that's what it is.
That's not how it is. No, okay, so it doesn't do that. The temperature varies coming out of the unit based upon what's required. Okay, so it's not like a regular boiler where you're sending out 160 degree water to all your baseboards all the time, and then it just shuts off. And the advantage to that is you don't have, as the price, you reach a temperature, you go past it, you shoot past it, and then it kicks off, and on a traditional, and then it goes down below a couple degrees, so you have a 4-degree swing. These things are very steady heat. They're, probably plus or minus 1 degree, assuming the temperature's not varying dramatically outside. If somebody opens the door or something like that.
yes, Greg.
Repeat the question.
Yes, yeah.
What technology has changed to make these efficient now?
The question is, what in the technology has changed to make these more efficient?
I was told I got to go over by the microphone. Sorry. Okay. The real change has been in the compressors. What they do, they're run off of AC power, and it gets converted to DC power. And then it can ramp up and slow down the compressor, whereas in the old days, most of the air conditioning units you see around, and this all comes from air conditioning. You talk to guys who put this in, it's all about air conditioning, not about heating, but it really is both. So in the old days, again, that compressor was either on, maybe they had 2 speeds. Now it varies dramatically. The amount of variation is pretty dramatic with a DC motor. So that's really it's a pretty small box, but there's a lot of technology in that box. It's pretty surprising. And that's the major change.
I'm just going to go here.
I actually have 2 questions. I want to circle back to the question that was raised earlier when you were in the midst of your presentation about electricity costs to run the unit in general, so that when we think about that bar graph where a high efficiency home would otherwise burn 500 gallons of oil is down to like 14, I think the bar graph said. I want to know, what kind of costs, additional electricity costs are related to that. And then secondly, I'm really curious about the capacity of these units. This isn't all about me, but I will tell you that I have about a 2,600 square foot home. So I'm wondering, and it's 2 levels with a full basement. I'm wondering, and I don't care about the basement
Yeah.
being heated a whole lot,
Yeah.
but, you know,
Yeah, what's possible.
yeah, what's possible? What's the capacity?
Yeah.
What are we
So the
talking about?
question, two-part question.
Excuse me, again, please stick to one question at a time.
Okay.
Okay, sorry.
Because I think I can remember them both this time. But, so the first question was, what does it cost to run a heat pump? In the earlier, there were dramatic oil consumption reduction with it, and so how much does it cost in electricity to replace that oil, essentially?
That's not an easy answer, okay? But what I can tell you is these are, so if you can do the math, but each house is different, and every situation is different. Sometimes these won't work in a house. If you've got a really chopped up house and you only want to have one inside unit, you can heat one room. It's like having a wood stove. The way I think of it, it's like having a wood stove, even though it's different, it's not radiant. But it heats a space. So if you can heat your house with 2 or 3, and you can put up to 8 heads inside units on these. So that's the maximum you can put at this sort of technology. So if you can spread that around, and they can be different size heads based upon the space that they're in. The electrical cost, if you know how many BTUs, let's say you don't change your usage, you don't change your insulation, anything like that, and you know how many gallons you burn, and you have to kind of figure out how much am I going to offset. But let's use this first floor here. We're going to heat this room. How much of this room is the heating load? Okay, and I don't know the whole rest of the space because I don't know the space very well, but let's say it's 50%. Let's say you're going to reduce your heating load by 50%. So if you're going to save, if using 1,000 gallons, you're going to reduce it by 50%, you're going to save 500 gallons, okay? That's a dollar savings based upon how you buy your oil or propane or whatever fuel you use. Then you can say, okay, well, these are 2.5 times efficient. So there's 3,500 BTUs per kilowatt. So you can work backwards and see how many kilowatt hours you're going to use for that oil use savings. And we can help you with that. I know this is not something you can just do on the back of a napkin, although we do. It's an estimate. And we also, if you do a weatherization project for us, we use Efficiency Vermont has a software program that will help you figure out how much you're going to actually save in dollars. They say how much you're going to save in oil, but they also increase the electrical use. So it's an art, but typically we use 200% efficient. Efficiency Vermont's doing a study. It's supposed to have been out summer. I think it's summer now, but it's not out yet. That they've actually had 12 units out last winter, which is a great winter to be looking at these, testing the electrical inputs, how much heat's coming out, getting a really good sense of how they're actually working in Vermont, all around the state. So when they get that information out, I suspect, Maine came out at 2.5, I think. So that's 250% efficient. So every kilowatt you put in, you get 2.5 kilowatts of heat out of it. That's one way of looking at that. So once that comes out, we'll actually have, it won't be hypothetical, there'll be some actual numbers for different types of houses, different locations in the state, so we'll get a better feel. My guess is we've been very conservative in how we've been estimating how much they're going to save people, and that's a good thing, because I'd rather have somebody be pleasantly surprised than, disappointed. Everybody, anecdotally, people we talk to, they can't believe they're still running when it's that cold out and putting out heat, and they can't believe that they work so well.
Yeah. And you think of them as a zone heater, because really the room that head is in, that you mount on the wall, is really the area that you're going to heat. It's not going to travel down hallways and through doors, typically. So it's a zone where you spend a lot of time, family room type of thing, put it in there. And then what you can do is you can typically reduce the thermostat in the other areas of the house, so you're also saving in that way, that you're not keeping the rest of the house warm, and you're able to keep the room that you're in most time warmer. Yeah.
if you're introducing heat into a room, why would you introduce it towards the ceiling and not at the floor?
That's a good question. These units actually have, the newest units at least, actually they go back a couple generations, but they have vanes in them. Okay, so they control the airflow vertically and horizontally.
So it can actually blow the heat
It
down.
blows the heat down. And actually they now have this little sensor that goes around, this infrared sensor that spins around, and it looks for the cold spots if you're heating and sends the air there. He's in control.
Would you repeat the question?
Sure, I'm sorry.
Yeah, go ahead. And then
Are the units single pole or double pole?
He wants to know if the units are single pole or double pole. The outside unit is double pole. It feeds the inside unit, which is a single pole. And
you said you can get up to 8 heads per unit?
that's up to 8 heads per unit is the maximum they have right now for these hyperheat units.
And so is there a small, medium, and large unit, or explain that?
Sure. There are multiple sizes inside head units. Typically they're 9,000 BTU. These are per hour. 9,000 per head. They're 15 and 18. But they make larger too. So those are the really super efficient ones that you got to be careful, because there's a lot of models out there, even within Mitsubishi, which is the brand that it's Structural Energy Corporation, by the way. So there's Fujitsu, there's other models out there. Mitsubishi tends to be the most efficient models out there, but when they're like every corporation, when they advertise that their brand new FH series has got a SEER of 30, which means that typically your window rattling air conditioning units, again, they're thinking air conditioning first, they don't think about heat. A typical window unit, even a efficiency window, Energy Star window unit is probably maybe 12, 15 SEER. These are 30 SEER. They're very efficient, much quieter, but that's for the 9,000 BTU head. As you start stepping up, the efficiencies drop a little bit. So you really, it is a good way of comparing, but you can't say, oh, it's 30 SEER for everything. It's just not. It's a confusing system, but it's actually, once you step back from it and look at it, if you look at a particular house, you can get a sense of whether, number one, it'll work. They don't work in every house efficiently. And number two, is it going to be worth doing that? Because they're not really expensive, but they're not free either.
I think we were going to go to him.
How does the efficiency on the air-to-air unit compare to the ones that are using an in-ground heat sink?
Sure. You want to know the efficiency, comparing the efficiency of the air-to-air to the ground source heat pumps. The ground source heat pumps are slightly more efficient. They used to be quite a bit more efficient, but they're not that much more efficient. Depends on how much they're significantly more costly to put in. Oftentimes you have to drill a well because you need a supply and then a dumping well. You don't always have to do that, but that's the best way to do it. I mean, typically, and we don't do ground source structural energy. We only do air to air. Typically, they're $25,000, $30,000 installed, the ground source heat pump. They are more efficient, so if over the space of life, their lifetime, depending upon the install cost, they might be a better deal over the life of it, but that's a pretty big chunk to chew off going in, whereas a single head inside unit ranges, depending on the size and some of the install issues, from, $4,000 to $6,000. So it's quite a bit different.
And typically your ground source heat pump is going to be a whole house heating and cooling system versus these more zone oriented, smaller units. Let's see, I think I said I was going to go there, and I'll come to you next.
You have up to 8 heads from one unit. How many thermostats would control that? Control that?
So the question is, if you've got multiple heads, how many thermostats control it? And I believe each head will have its own thermostat. So you don't have to run them all at the same time. You can heat and cool the room that you're occupying. Yeah. Yes.
We're building a new house, and it will be well insulated, double walls and so forth. So in addition to an air source heat pumps, since these are efficient down to only 13 below zero maximum, do you have any general comments about what supplemental sources of heat would be advisable in this climate?
Well, I have a personal preference, and that would be wood. So the question was, if you're building a new house and you're going to put these units in, how, because they're not going to do the whole house all the time. In colder weather, you're going to need a supplement. So what can you use for a supplement? I suggested wood.
Yeah.
I could speak to that a little bit.
Sure.
Maybe a quick
This
introduction.
is Jared Rhodes. He's the owner of Structural Energy Corporation.
Yeah, just hi everybody. Thank you for coming. I hear there was a rival heat pump presentation across the street, so I'm glad you're all here. My company, Structural Energy Corporation, we're right here in Middlebury. We do energy efficiency projects, energy retrofits through the Efficiency Vermont's program, as well as high-performance construction, remodeling, restoration. And we've recently got into heat pumps.
Could you use the mic?
Oh, okay. Is it, yeah. I just wanted to give a general overview of how we got into this and why we think heat pumps are important. We want to look at the house as a whole. So we generally approach this by going in an initial energy audit, looking at the big picture for the house. All the energy-related issues, the heating systems, the thermal envelope, as well as the building durability, the roof, the foundation, everything. And then we sort of do an analysis on improvements, and they can be related to the building itself, insulation values, air leakage, the heat system, and then once we have all that information, we can analyze and carefully calculate how well one of these is going to be, work for that particular home, and carefully calculate what the rebates are. So that's sort of how we got introduced, and we decided that these systems are simple, cost-effective, generally easy to install. I mean, you saw on the list that they're number 2 in the ranking of cost-effective measures for your home. We have Rick and another employee have recently gotten trained through and licensed through Mitsubishi to install these, and our approach is to add them to a work scope for an overall energy efficiency improvements for the home, because each home is different. They're complicated. There's a lot of issues, as we're talking about here. The size of the room, the existing heating system, how it's zoned, the existing thermal envelope, how tight the house is. There's a lot of factors here. So I think, when we look at these heat pumps, we really want to look at the house as a whole and really figure out how it's going to work. To get back to your question, for new construction, we actually are able to build these houses with such an efficient thermal envelope that they can be heated exclusively with a heat pump. In fact, we're building a house in Leicester later this fall to the standard set by Efficiency Vermont. They're called the High Performance Standard. There's High Performance Energy Code Plus and the Basic Energy Code Minimum construction. When you build to the High Performance Standard, that system, the construction of the walls, the foundation, the roof, the windows, is designed so that you can heat exclusively with a heat pump. And when you hit those negative 14-degree days, the theory is that house holds the heat so well that it's going to just retain that heat until it warms up enough where the heat pump works again. That being said, the house we're doing in Leicester, we're putting in a wood stove.
There you go.
They're generally tired and old.
Wood stoves are nice.
How about pellet
You don't have
stove?
to carry the wood,
Well, an interesting thing about this particular house is that it is not the typical open floor plan, that a heat pump works best for. It is kind of chopped up. So they actually have to make the commitment to leave doors open to different rooms so that space heat can get everywhere. And because it's so tight and thermally efficient, it will distribute fine as long as you do that.
If you are using wood as a supplemental heat, will the air source heat pump produce enough heat to prevent, say, your pipe from freezing on very cold days if you are away for an extended period of time and unable to feed a wood stove, say? It won't produce enough heat for a comfortable living environment, but will it produce enough to protect your home?
I think, yeah, I'll let, he's the technical.
Well, he's concerned about whether with a wood stove, if you're not at your house, will a heat pump supply sufficient heat on a very cold day or night to keep your pipes from freezing? And that really is as much a question about how much insulation is behind the pipes, because typically they run in the exterior wall, and sometimes there's, you know, some fiberglass stuffed behind there, and that's really, you're borderline even when it's not that cold. We had a lot of houses that pipes froze this year in Vermont because it was really cold at night.
Even with heat running full blast.
Right.
You know, and they do shut down at negative 14 degrees.
Right.
It's not that they just wind down and don't produce enough heat. They actually shut down to prevent freeze up. Is that right?
Yep, that's correct.
Do they then trip a resistance heater?
You can actually get a resistant heater in some of them. Yes, you can. Typically, though, people have, particularly in retrofits, there's already a heating system there. A new house is somewhat different. So you can always have that as a backup. I mean, wood heat is great, but if you're not around, that is a problem. So, I mean, pellet stoves, if you've got a big enough hopper, yeah, that can last for depends on how long you're away for, or if you got a neighbor or a relative, better relatives than mine to rely on, come in and fill it up. So yeah, it can work, but that's where sometimes, oftentimes people have a Renai through-the-wall propane heater, something that they don't really want to use. It's only there for emergencies, particularly if, in almost all of these heating systems, when the power's out, you don't have heat. The heat pumps, most of your propane, oil. So this is not anything, you know, most of your pellet stoves, they might have a battery backup.
The direct vent gas things will run without, most of them, some of them, yeah, let's go with some of them, will run without power. You know, certainly fans aren't going to work then.
Go ahead.
The question is, are there air source heat pumps that tie into hydronic systems? And they don't really tie in because, you know, hydronic system is obviously a water based thing, could be in the floor or in a baseboard type of thing. And these are air heaters.
I mean, in terms of, so you have the outside compressor, and it's running refrigerant, that could go to an exchanger to like a storage tank.
Yes. It actually, Dakin, there's a German product that actually does air to water. The problem with it, depending upon, for baseboard radiant, which is most people have in their house, that requires a temperature higher than you're probably going to get. Now, if you're doing radiant in the floor and have extra loops, if you plan on it, you can use a radiant in the floor, do an air to water. Dakin is the name of the brand. You can actually do that. If you have a furnace, there is air to air, but you put an A coil in the duct system, so you can actually heat your whole house if you have a duct system. But again, that's typically for a house that has that in place, because running ductwork is very expensive, and the efficiencies drop. The beauty of these things is for the space that they're heating, they're very efficient. Anytime you have ductwork, they actually make ducted units for this. You have an outside unit, an inside unit, and you can run ducts off it for a small area. We're looking at one for an office. The efficiencies drop pretty dramatically when you do that, but it may be the only thing. So there's a lot of opportunities. There's floor units, too, that you can get. So there's options, but the wall-mounted unit is the most frequently used. It's out of the way. It's sort of, you don't even know it's there after a week, to be honest with you.
Simple to install.
Yeah. Go ahead.
Okay. Yes. There are two ways in which we can look at the recapture of our investment energies. One is the year in, year out, how much efficiency are we getting? How many dollars are we saving on running this device? The other cost recapture or cost efficiency that we as homeowners or real estate operators would be concerned with is what impact this has on the resale value of the installation. Have you got any notion of that?
The question is, how do these things affect resale value of the home and that? And the appraisers group, whatever they're called, they are starting to take into account all these efficiency measures and high efficiency units that for heating and cooling, insulation, weatherization, things that have been done. So the appraisal world is paying attention to it now more than they ever have in the past. Yeah.
Even when you buy some kind of unit or, you don't know how long that is how long do you typically last?
The question is about longevity and how long will these units last, and I'm going to pass that over.
They're relatively new, so they've been around. The technology's been around. So if you look in Japan and Germany, where they're all over the place. And Germany, they have a very similar climate to Vermont, actually. So one thing I can tell you is they have a 7-year warranty. Okay, so that tells you something about it. Doesn't necessarily mean year 8 is not going to die on you, but that's probably better than a lot of furnaces, actually, and boilers. And then the technology, even though it's new to this zone, this heat pump, cold climate heat pump, it's well tested. Refrigeration has been around for a long time, and so this is not new, except in the fact that there's these reversing valves and DC compressors. And even if you had to replace it, these are a lot of parts. If a compressor dies, you can replace that relatively inexpensively. It's not, I can't say it's, from what I understand is you don't have to do that. They haven't had any they really had to do unless, and it usually is the first day you put it in, you know you had a problem because it's a manufacturer problem. And that's totally under warranty. Once they start up, now if they're not installed properly or like that picture, they're covered with snow, that's a problem. So I can't answer it.
I think the general consensus is they're pretty simple systems. Even though they're very technological, they're fairly basic. They have been around, and the general feel out there is that they're a very durable, low maintenance, long life system.
Yeah. We're gonna go.
So if the power goes out for 3 days, what happens?
So the question is, what if the power goes out for 3 days in an ice storm and it's cold? You're going to have problems, unless you have a backup heat source that is not relying on power. And that's really the case for any, if you've got a furnace or a boiler, nothing's going to work unless you've got a backup generator to power that. So it's really in the same boat as all the other powered sources of heat that.
And I guess the second question is, my folks have a kerosene heater right now that my dad likes to sit next to. Could this be mounted up above it, and what would that mean?
So the question is about
you. Want to change it? Could this somehow?
Well, I have some pretty strong opinions about kerosene heaters. It's a big indoor air quality issue because it's a non-vented fuel burning appliance. And oh, it is vented. Oh, okay. Pardon me. Yes.
What's blocked? One thing I do want to stress about these systems, the way we look at them, is that they are designed to offset a portion of your existing heating system generally, unless we're approaching it from a new construction where we're doing things differently. So we have to look at the ability to shut down a zone of that and put that heat pump in there. You know, if you're looking at shutting off that kerosene heater and using the heat pump, and then if the heat pump gets too cold or doesn't, or whatever, you know, you can have that backup, the kerosene back it up by turning on. You know, we're really not trying to replace or change existing systems, generally in a retrofit situation. That's, you know,
I think it's more the reverse, that the, you know, sitting next to something that's warm.
Yeah.
I got you. I got you.
It sounds like the heat pump is not going to do that.
It is not that, I will say. I mean, you know, a wood stove that radiates heat, you sit next to it, it's cozy. This gives you very even, comfortable temperature throughout the whole room. So you're not necessarily going to want to huddle up next to it.
Yeah.
You know, it is blowing warm air, so I suppose you would, you know, but no, it's not that radiant, warm, comfortable thing to huddle around and read a book.
Yeah. Go ahead.
Getting back to that snow, is there an optimum position for locating the compressor? And how would you protect it from snow in the best of all possible circumstances?
Well, so the question is about placement of the outdoor unit, which is the compressor. And you want to raise it up above snow level. If you can put it on an eave, away from an eave where snow's not going to be coming off of it, that's good. A roof over top of it will keep snow away from it. You know, if you've lived in your house for a while, you know where the snow builds up and that, and kind of have an idea like that.
And I don't think you're required to have a roof over it for warranty, but we kind of generally feel it's a good idea.
Yeah.
You know.
Yeah.
I mean, you want to have good airflow. The fan that's on that outside unit is either when you're air conditioning, it's trying to take that heat away. It dumps it out there. So around that unit, it gets hot in the summer. So oftentimes you say, let's put it underneath the deck. That's not a great idea, number one, because usually it's restricted airflow, but it also means that heat's going to rise. Anybody sitting on that deck, it's going to rise across you. If you're going to use it only for heating, that's probably not an issue because you're going to be probably not sitting on the deck when it's on. But you might. And that's going to be, in the winter, it sends cold air out there. So it makes the area colder around it. And that's where you start worrying about freeze-ups and stuff. So you want to have it, they recommend 18 inches off the ground. Use a stand that will hold it up that far. And even at 18 inches, depending upon where it's located, if the wind's drifting, it's, as a homeowner, it's sort of general maintenance like you would with any through-the-wall furnace or something like that. You want to keep that sort of clear snow if you can. I would highly recommend that.
Yeah. Go ahead. Ladies first.
What sort of maintenance is involved in this, and is there any sort of recharging for refrigerant or coolant, and any kind of filters that need to be dealt with as an ancillary cost?
Yeah. There's the refrigerant, you shouldn't have to replace it unless you've had a leak. So that's pretty straightforward. There are filters on it, and there is a condensation tube that drips to the outside, and that needs to stay clear.
And that's only, the condensation is only when you're air conditioning.
Yeah. Okay.
And there's multiple filter options. You know, the basic one is just a dust filter, and you can flip out the door, you can wash it in the sink, you don't have to buy new ones all the time. So it's a pretty simple, they say, you know, at least once a year, a couple times a year is a good idea. Then you can get higher and higher filters out, all the way up to charcoal filters, so they can actually, it can become, since it's moving air, the room, circulating air in the room, it can actually act as an air purifier too. So that's, some people have, you know, they want it for air conditioning because they have breathing problems, they have COPD or something like that. So this is another plus. Now those you have to maintain a little more, and they're, you know, they're an add-on, but they're available, and you know, so that most people don't get those. They just have a dust filter, and you want to clean it out because you want airflow both on the inside and on the outside because it's moving heat. You want to get it away from that unit.
Go ahead.
What can you tell me about sound levels inside and out of the unit running?
Yeah. The question is about sound levels inside the room.
And outside.
And outside.
The fans are, I personally don't like sleeping with fans, so I don't. These are very quiet. The outside unit, oftentimes you don't know it's running unless you look and see the fan going. They're amazingly quiet. They do make, I have to say though, when they're switching or shutting off, if you know how your refrigerator, when it shuts off, there's this trickling sound, because that's refrigerant changing state in there. So there's some odd little noises like that. But most people who want at least 2 heads, they have this great room they want it in, and the other one they want in their bedroom. Because even though most Vermonters are rugged and hardy, they can get through any summer day. It's the summer nights when it's a real drag. So having air conditioning in your bedroom is where people typically want air conditioning. So that's just a consideration. So it's quiet enough to be in the bedroom, I guess, is the answer to that.
Generally they're very quiet. People have different sensitivities to that. You know, the cycling on and off can be an issue. We generally don't like to put the outside unit right outside somebody's bedroom window, you know, because of that. But generally they're quite quiet.
Yes.
Any word on the new incentive program from Efficiency Vermont? The last I heard, they were due to come out with something in October on that.
The question is about the Efficiency Vermont incentive programs, and at this time, there's no, that I'm aware of, any firm thing about it. There is something coming, but we don't know what. I do know, just as an aside, that this is kind of related to it. Air source heat pump hot water heaters. Efficiency Vermont just is completing a $400 rebate program, and it's up to $550 now. So,
I'm sorry, you said air pump water?
Water heaters, yeah.
Yeah, we haven't talked about those. Similar technology, a heat pump on top of an electric water heater unit. We've been installing those for over a year now, pretty effectively in the right situation.
Yeah.
You know, it's taking heat from the air of the room that it's in, typically a basement, and using that heat to preheat the water.
Yeah, and if you've got a wet basement, you get a double bonus because it acts as a dehumidifier at the same time, so you can cut back on your dehumidification use. So you know, there's some synergy going on there that makes it even better.
Those are typically about 60% more efficient than a standard electric hot water heater. They cost around $3,000 installed.
Yeah, but very effective. If anybody here has an electric hot water heater that's about to bite the dust, look into air source heat pump water heater. It's a very simple conversion. Yes.
You mentioned humidity. It's often dry in the winter and moist in the summer. What's the heat pump do with that?
It's not a problem. It just when you're the air conditioning mode, what you've got cold surfaces that humid air condenses on.
So it doesn't impact the air that's coming into the house moist? Or does that reflect nothing?
It doesn't affect, I mean, when you're air conditioning, there's 2 modes there. So when you're air conditioning, you dehumidify. So, and it's not taking outside air in, it's recycling the air within, you know, obviously there's air coming in naturally, but if you've gone through weatherization, hopefully not too much. And that's one of the reasons in the winter it's dry, is because the outside air that's very low humidity, and it's cold, and you bring it inside, it's even lower humidity because it can hold more moisture, but it isn't there. And that's why you get static electricity. People say, well, the wood stove creates that. The wood stove doesn't create the low humidity. It's drawing that outside air in because it has to feed the fire. And that's where you start getting static electricity and stuff in the winter. So it's not going to help you in the winter bring up the humidity level, but it will help you in the summer. Actually, they have a dehumidification mode on these too. If you didn't want to cool, you can just dehumidify, although that's sort of the same thing, but it is a little different. So yeah, it will help you in the summer, and it won't change the humidity in the winter. Well, I shouldn't say that. If you've got a wood stove and it's dry now and you don't use your wood stove, it will help you because you're not drawing that outside air in as much.
about being able to have 8 heads on one of these things. Does each room need to have a hole drilled through the wall to the outside?
Yeah. So the question is on the multi-head units, what structurally happens? And yes, each is going to have a refrigerant lines coming to it and its own condensate line and its own thermostat.
It's a 3-inch hole.
Yeah.
And all connected back to this?
Back to the outside unit,
Yeah.
yes.
Outside or inside?
The outside unit is out. Well, you can run the lines inside or outside. Depends. You know, you do. One of the key thing is you got to get the drainage when you're air conditioning. Even if you say I'm never going to air condition, if somebody puts an air conditioning mode, you need to get rid of that water. So that's really the controlling issue as to where to put the line sets, because you want drainage. The drainage doesn't have to be with a refrigerant technically, but it typically runs in the same container, and it's called line hide. So you can put them on inside walls, but you still got to get drainage to the outside as quickly as possible so it doesn't back up inside. Okay? So yes, you can have them on any wall. Typically they're done in the exterior walls because that's the easiest place to get the drains out. In new construction, you could plan on having it run through an interior wall much easier than in a sheetrock wall, tearing it off to get drilled through the studs at a slope so it drains away. So that's why from an installation simplicity and cost, they end up on the outside walls. They don't have to.
And one point regarding the outside lines and it running up and in through a wall and having the unit mounted on the outside wall. One of the biggest drawbacks to these I see that we run into is the aesthetics of these units. You know, you are putting this box with a fan, you're running a line holding the refrigerant and the condensate drain up a wall and in through the house. So it's very visible. So that's often a big consideration.
They're in like, you know, they're called line hides, but they really are a gutter. That's what they look like. That runs up, and you have choices of colors, and they're not great. You can get fancy. You can go inside and do it in the basement if you can, you know, as best you can. But it's typically, again, it's on the outside of the house. And with eight units, you actually run just one line inside. There's a box inside that has, then it splits from that. So it starts inside. It gets, obviously we put men on the moon, we can do anything. The more, we used to put men on the moon, the more heads you have, the more complicated it starts to get. 2 heads, 3 heads, that's easy. Start getting 4 heads and stuff, you get this combiner box. It makes for installation expense, to be honest with you. And more planning as to where the lines are going to run and where's the drainage going to go and all that stuff. It's not impossible. But if you want to keep it simple, which I recommend, 2 to 3 heads, no problem. If you want 4 to 8, we can certainly do that, but it will cost.
Regarding costs, I'm sure that's a big question. The simple single unit systems, I think we're finding that the costs tend to be between $3,500 and $5,500. When you're talking, these multi-head complicated units, up to 20.
Probably for 8. I've never put an 8 in. I know, for 2 head units, they're about $7,000. Again, it kind of depends. If you want 2 really large inside units, that's going to be more than 2 smaller inside units. So there's a lot of permeations here. So it's just as a rule of thumb, I would say about $7,000 for a 2 head unit installed. But it may go more than that, and it might go somewhat less than that, depending on and how much line you have to run and where's the one thing we haven't talked about. These are on electrical, and I'll call you. You got to have enough room in your electric box. You got to have at least a 2-pole breaker available. This is a 2-pole, so you got to want to have. Typically, these are a 20 amp supply. It's not huge, but the larger you get, those bigger units are actually when you get over 4, they're 2 outside units stacked together, so they get to be bigger, and so it's not just the refrigerant and the units. You have to make sure you got enough. Oftentimes we've gone in and there's a 100 amp service that's probably should have been changed out 10 years ago, and now they want to add this to it, and there's just no room. So then they have to look at upgrading their service panel. So that's if you've got 200 amp service, you're probably okay, as long as you don't have jacuzzis and all that stuff coming off it.
This is 20 amps, 220?
Yeah.
Yeah, for most of them, yep.
Yes.
I hear a whole lot of what ifs and gosh, you might need this and that, the other thing. Could you kind of walk us through the planning process? We walk out of here tonight, we're interested. What do we do to find out what we actually need and what's going to work best in our house?
So the question is about the logistics and planning process. How do you get the ball rolling?
We come to these in two basic different ways. We're at a house, we're hired to do an energy assessment of the house, to look at the house as a whole, and we will, if it makes sense, we'll propose one of these and introduce somebody to these technologies. The other more frequently, what's happening is people are hearing about this great technology, calling us, are interested. We go out to the house, talk to the homeowner, look at the situation. We don't have to do a full comprehensive energy audit necessarily, although we do recommend that, but we can tell a lot from your home just by spending 10 minutes there. And we'll look at the location you're interested. We look at where it has to run, where it's located, the electrical, and those things, the size. We have to size the unit, and then we would come up with a cost for that. And they typically take 2 guys a day and a half to install. So it's a pretty quick install generally for a simple system. Yeah.
You still.
Oh, sorry.
Then.
Okay.
Yeah.
I'm used to turning down the heat at night and turning it up in the morning. How quickly can the temperatures fluctuate between, that cool night and that?
And the warmer morning. So the question is about response time and how quickly will they heat a space or cool a space. And you guys want to hear?
They are, I would compare them to radiant floor. They're a little faster than that. They're not like your 100,000 BTU furnace kicking on and just within 10-15 minutes it's raised. They're slower. So, but the advantage to these to some extent is that they're pretty even heat. So having a more steady heat and using these more than letting your furnace kick on. Let's say you turn this one back and then your furnace kicks on in the middle of the night because it gets below whatever that separate temperature is. The best use of these is to have these run as much as possible compared to the type of fuel you're trying to offset. But again, you can set it back. You can have a remote. You can also get a regular thermostat similar to this. It's an add-on because they use remotes as standard. But you can have it so that you can have set back temperatures for each day and stuff like that if you want to do that. And you can also change the temperature with your phone if you want, if you've got a link and all that stuff. And one of those things is, if you're away from your home, and the gentleman asked about being with wood, there's a Nest, is this new hot thing came from Apple. It's a thermostat that you can check and change the temperature and do whatever you want with your phone. But it also, you can set an alarm. So if you're away and the temperature drops below 50 degrees, it'll send you a text, I think, so that's a really valuable service if you're traveling and you don't know the power's out, or the power may not be out anywhere else except your house because a tree fell down and cut your line. Nobody knows about it. So there's some advantage to that. I'm not advocating that, but you can have a setback thermostat as a simple answer to that. But you're right, there is a slower recovery time than a traditional heating system.
Okay. Yes.
You said the compressor turns off when it's below 14 degrees or 13 degrees. Does it turn itself on, or do you have to go out?
No. It's negative 14.
Negative.
Yeah, not just 14. So at 5 degrees, they're 100% what they're rated at. So if you have an 18,000 BTU unit at 5 degrees above zero, they're 100% that. And so when you're 45 degrees, these things are, we talk about those COPs of 1.5 or 2.5, excuse me. But when it's 35, 40 degrees, they're much higher than that. So those shoulder seasons, like if you're burning wood, that's the hardest time to heat because you start that wood stove up and it's just too hot all of a sudden. It's 50 degrees. It's hard to run a wood stove when it's 50, 55 degrees. But these things work really well at those temperatures. They're moving heat real easy because the more that's out there, it's easier to move.
So that the unit turns
itself. Oh yeah, absolutely. You remember?
I did remember the question.
Okay. Any other questions? Yeah. Oh, one more question. Yes.
We have a cabin, so it's a very small place, and we have a Dakin and 2 splits. And it seems like on one of them, there's a defroster. So those shoulder seasons, that's when we use it. It's great, but there's a little thing that comes on that says it's defrosting outside. So does that, and I don't know if we have one of these super cold weather ones. We just got it a year ago. But there is a defroster thing on that I think the compressor outside is defrosted.
Yeah.
Yes. And that's sending heat out to the compressor so it doesn't freeze up?
Yep, and that, so the question is, how does the defrost cycle work in these? And that is a conventional electric resistance heat type of thing. So that's, when that is happening, that's one of its least, it's probably its least efficient operation.
Actually, it's not even operating when it's in defrost mode. It's, you know, and they, depending on, it's trying to clear the coils of ice. It's like, you know, you're not supposed to have ice in your freezer. Nobody has ice in their freezer built up, right? Because that means it has to work that much harder. So the less, it knows when it's starting to get built up, and it goes into a defrost.
And it was below 0. I mean, it was a cold winter.
Right.
Yeah.
So.
It sure was.
Yeah. Yeah. Okay. Well, if there's no more questions, I'd like to thank you all for coming.
I think